Welcome to part 7 in this video series, using the Analog Current AOI. In this video series, we're going to be introducing the Analog Current AOI. We'll also be importing the Analog Current AOI into the PLC project. Then we will learn how to configure the AOI for current analog control. We will also explain the PLC tag structure the AOI creates that makes programming the AOI user-friendly. So let's get started with the Analog Current AOI. With everything else, before we begin, we need to understand the physical layout of the particular analog current module that we will be working with. In our particular graphic here, we're going to be working with this particular module right here. This is module number 2. This is the second module from the left of the COM module. The COM module is located here. This is module number 1, which is an analog voltage module. Module number 2 is an analog current module installed here at this particular location. We will need to remember that this is module location number 2 when we configure our add-on instruction. We will also need to be familiar with any kind of electrical pinout and wiring with our analog current module. In this particular case, one of the port numbers here shows the pinouts of our analog module. The analog port has one input and one output analog. Pins 1 and 2 are associated with an analog output. Pins 3 and 4 are associated with an analog input. Please remember to wire your analog device accordingly. If you've watched our other video series, you'll notice that the analog current module is exactly the same as the analog voltage module. In this particular case, the front panel shows that we have 4 available input ports and 4 available output ports. Port 1 has an available input raw value and an output raw value. These output ranges are very similar to the analog voltage module, where there's an integer range that is associated with a raw value. The range is anything from 0 to 4096 integer. We use this value to interpolate a voltage or a current depending on which module is being used in the analog configuration. For the purpose of this video demonstration, we're going to be using an analog current simulator, where we can simulate the current from 0 to 20 milliamps on port number 1. We have our simulator connected to module 2, port 1, input number 1. If you've been following along with us in this video series, we've been using this sample project called MAC. We've already imported 3 AOIs so far in this video series, including config module, solenoid control, and analog voltage. The SCP add-on instruction gets imported whenever we use an analog AOI. Let's go ahead and import our next AOI, which is the Analog Current AOI. We can do this process by right-clicking on add-on instruction and selecting Import Add-on Instruction. We will go ahead now and select the Analog Current AOI and import that particular AOI into our example project called MAC. At the time of this video series, we are still using version 1.0, which is an analog current AOI module that controls current from 0 to 20 milliamps. We'll go ahead and click OK here and allow the AOI to import into our project. Once we have the AOI imported into our project, we are now offline with this particular sample code, so we will need to create a new rung of ladder logic to drag and drop it onto and into our PLC project. We can do this by dragging and dropping it from the folder, or we can go to the add-on toolbar at the top and find the particular AOI that we want to import and drag and drop it from the toolbar. In this particular case, we're looking for the Analog Current module version 1.0. We'll go ahead and left click on it and drag and drop it onto a rung. Just as previous, naming our AOI tags are extremely important to help us find the tag name structure in our PLC program. We're going to go ahead and follow the same naming convention that we did earlier by naming our particular AOI a station name. Because we only have one valve stack, we've been referring to our valve stack as Station 1, and our analog current module is installed in Module 2. So we'll go ahead and give this particular AOI a Station 1 Module 2 underscore AOI tag name. Because we are referencing the exact same valve stack, we can go ahead and drag and drop the input data and output data from a previous AOI. We can left click and hold and drag and drop that particular tag name valves.i.data into the particular mapping location that targets the valve stack that we're wanting to control, this particular add-on instruction. We'll also need to give the analog current a config tag name. This is the name that we will use throughout our programming, so it is important to give it a name that is meaningful to you. In this particular case, we're going to be calling this Station 1 Module 2. Once we've created our two tag names, just as always, we're going to right-click on them and select to create a new Station 1 Module 2 AOI. This particular tag will be associated with the analog current. We'll also need to do the same for the config tag name. The last thing that we need to do is we need to tell the AOI where the target location of the analog current module is. You could have multiple analog current modules installed in the same valve stack. In this particular case, we only have one analog current module, and it's located in module location 2. Once we've declared the module location, now this AOI will read and write to that particular module location. It is very important to set this module location appropriately for each of the add-on modules. Once we've successfully configured the analog current module, we can go ahead and save our sample project and now download it into our PLC by selecting Communication and Download. This particular process works if the path name is already set appropriately to the PLC target. We'll go ahead now and select Download to download this particular AOI and rung 5 into the PLC. We already have our analog current simulator connected to port 1 input, and we can start to see some raw values already being registered on that particular port. Before we begin using this AOI, let's first take a look in the manual, where there's a table that describes the analog current module callout for the tag names. We are using a common UDT for all of the add-on modules, which means that not all of the tag names are being utilized depending on which particular module you're using. Because we are using the analog current module, we are not going to be using the .input, .input1 or .input2. Likewise, we're not going to be using the output1 and output2 tag name booleans. And because we're using the analog current module, we will not be using the input voltage terminals or tag names that are associated with this particular AOI. However, now that we are using the analog current module, we will be using the tag name input current and output current tags that are associated. It is always recommended to look at the manual, which has this table callout of which tags are being utilized depending on which add-on modules are being used currently. Let's go ahead and take a look at our AOI that is now currently running in the PLC. If we go to Controller Tags and look for the tag name that we created earlier, we can find it here under Station 1 Module 2. Station 1 Module 2 expands out each of the particular port numbers. Because this particular module is an analog current module, it only has 4 physical ports, so only the first 4 ports are being used in the tag name. Ports 5 through 8 are not being used whenever this particular tag name structure is used for an analog current device. Since we have our current simulator connected to port 1, let's go ahead and take a look at the values that are being shown inside of the port number. Here we can see that we are registering a value from port 1 input. We can see a raw value of 1632 integer that's being reported on port 1 input condition. This is being translated into 9.58 milliamps. Because this is an analog current module, the current reading will be from 0 to 20 milliamps. Our current simulator, for the purpose of this video, is not calibrated. We can use the adjustment on the front panel to calibrate or tweak the actual current value that's being shown on our simulator. This is what the calibration value tag is utilized for. Here we can see that our simulator is inputting a current value of 11.28 milliamps. This is very close to the actual value that's being reported on the module. We have some fluctuation here that's in milliamps, but occasionally you can see 11.28 milliamps. Because this value is very close to what we need, there is no need to make any kind of a calibration value adjustment. If we had a difference between our measured input analog here, we can make an adjustment with the calibration value. We can make a negative adjustment. We can put a value of -100, which then affects the raw import value that's being calculated inside the AOI. This will then change the analog current value that's being reported inside the AOI. Here you can see with a -100 integer value, we have adversely affected the actual value of the current simulator that's being shown. Now, the add-on block thinks that the current reading is 11.6 milliamps. We can also make a positive calibration value to swing the value the opposite direction. Now the current shows 10.95 milliamps. Because the value is very close to our simulator value, we're going to go ahead and change the calibration value back to 0 integer. And now we have restored to the actual value that's shown 11.28 milliamps. Now that we have a calibrated milliamp reading coming from our simulator, we can now utilize the scaled minimum and scaled maximum output. When you do programming with an analog device, typically you want to take an input condition that is an analog, which may be a transducer in this case. So let's take for example that our transducer is 0 to 20 milliamps, and we need to associate a milliamp reading with something that means some sort of a measurement to us in the real world. Let's make an assumption that our transducer measures anything from 0 inches to 100 inches. Once we have inputted a scaled minimum and a scaled maximum, now the current that is 11.28 milliamps is then translated into inches. The scaled output is 56.37 inches. Because we're using scaled minimum and scaled maximums, which are then using this scaled with parameter add-on instruction inside of the AOI block, we can set the minimum value to anything we want and the maximum to anything that we want as well. And now 11.28 milliamps equals 607 inches in this case. Let's go back to our 0 to 100 inches example. The output current works exactly the same as the input current, only in the opposite direction. Taking for example the same where we want to control a cylinder, let's say, and we want to move that proportionally with, say, a proportional valve. We can go ahead and scale a 0 to 100 inches for a theoretical valve. If we want to move the valve to 50 inches, we can input 50 inches on the scaled output, and this will send a 10 milliamp signal out on the current port. 10 milliamps is exactly half of a 0 to 20 milliamp output, and this also is represented in 1706 integer on the raw output port. You can see that the analog module and UDT structure makes it very user-friendly to set up scaled minimum and scaled maximum outputs to utilize an easy-to-use correlation between the current and the actual output that is meaningful to you in the programming world. Thanks for watching part 7 in this video series, Analog Current AOI.